we're done discussing how to ortho rectify or georef scanned maps. And as a continuation, we will be now talking of how to digitize our map using three common vector types, namely point, line, and polygon. Before we proceed with the actual hands-on, let's have a quick overview of these three different vector types. First things first, vector data. These vector data actually provide a way for us to represent real-world features within the GIS environment. And a feature is anything that we can see on the landscape. So for example, if you have a map and you have a different, for example, that particular map could have different features. For example, you have a land feature, you have a, in terms of land, you have maybe, for example, perhaps you have volcano, perhaps a hill. Also, you could have vegetation or structures, and each one of these features, we represent them in GIS using either a point, a line, and a polygon. And these vector features have attributes or information which consist of either text or numbers, which are information that describe these particular features. In GIS, as mentioned, we could be referring to a point feature, which consists of only a single vertex. And this particular feature, this point feature, would tell us the exact location in terms of the coordinates. So if you want to get the exact coordinates of a specific feature on the map, then we can use a point feature. Now, if we want to measure length, then that's the time that we use a polyline or line feature. Basically, a line feature or a line geometry consists of two or more vertices, and the first and the last vertex are not equal. Now, where there are three or more vertices that are present, and the last vertex is equal to the first vertex, then that's the time that we have an enclosed polygon feature, which is used to measure area on our map. Again, a point feature is described by its x and y coordinates, and perhaps optionally it could have a z coordinate. The point attributes describe the point feature. For example, if you are digitizing a electric post, the location of a structure or a specific tree species. Now, for a line feature or a polyline, this is a sequence of joined vertices, and each vertex has an x and y, or again optionally a z coordinates. And for the polygon feature, it is like a polyline, and it is composed of a sequence of vertices. However, for a polygon feature, the first and the last vertices are always at the same point. And this particular vector type or feature is used to measure areas. Okay, so now let's proceed with the actual hands-on. Okay, so let's go to the hands-on. Of course, we have to open our QGIS. So this time, supposedly I'm planning to sample the georef map that we have last time. But for this exercise, I'll be using real-world features, particularly islands within the exclusive economic zone of the Philippines. And for this exercise, I'll be loading polygon data showing the different exclusive economic zone of the countries in the world. Later, I'll be including the link of this site where I downloaded this shapefile. So again, I'll be loading the shapefile for this exclusive economic zones. So the vector type for this shapefile is polygon. Okay, so here we have the showing to you the different exclusive economic zones of the countries in the world. So in particular, I have here the Philippines. What I want only to sample is the EEZ of our country. So I'll be filtering these polygons here. So I'll be going to filter the polygon features of this exclusive economic zone. Instead of single symbol, I'll use rule-based because I just want to show the exclusive economic zone of the Philippines. So I'll add, first I'll input the label Philippines EEZ or exclusive economic zone. Then under the filter, I need to type in the expression. So first I'll go to fields and values, and since I know what particular field that I want to filter, which is I check the attribute table beforehand, so I'm sure that this is the correct field. Geo name, then equals, and I'll have to hit all unique for me to be able to select the Philippines. I'll type in here Philippines, and it should return the Philippines exclusive economic zone. So double click and then click OK, and then I'm not sure if the expression is correct, I'll have to click test, and it should return the number of features that is okay. So I have here I have filtered one feature, meaning my expression is correct. So click OK, and I'll be deleting this one. So what it does is that it will only show the exclusive economic zone of the Philippines. I'll hit apply and click OK. So here we have the polygon showing us the exclusive economic zone of the country. And then since some of the islands within these exclusive economic zones are not shown, I want to remove the fill of this polygon. So I'll go to the properties, then instead of using a solid fill, I'll use no brush, and then for me to be able to easily see the outline of this polygon, I'll change the color to yellow. Click OK, click OK. Okay, so that way we will be able to see the group of islands or islands within this exclusive economic zone of the country. In particular, I want to sample the Kalayaan group of islands here, and let's try to check some of these islands, and let's try to pick the best island for us to be able to sample when to use a point feature, line feature, and a polygon feature. So let's try to see, let's sample. Perhaps this might, let's try to sample this island, perhaps this one. Okay, this is just a simple island without interesting structures. Perhaps um, how about this one? Perhaps this island can have some interesting man-made structures. Okay, just another barren island. I want to have the island which have some structures, man-made structures, for us to be able to sample point, line, and polygon. How about let's perhaps this one. Zoom in. Okay. Okay, so let's have this island here. As we can see, this particular island among the Kalayaan group of islands have some interesting man-made structures. So let's try to scan the different structures within this island, man-made structures. So first, we can see that this island here, it has a runway. Okay, this is a runway, which I think is not intended for domestic purposes. Okay, runway, and we have structures beside it. Perhaps this is the control building or airport, or part of the ancillary facilities within this runway, this airport. Perhaps this is the control tower. So later on, let's sample, or let's use this runway for our line feature. We will try to measure the length of this runway. So let's scan the islands. Okay, so we have a lot of structures, man-made structures on this island, and this feature on the ground seem like they look like, if I'm not mistaken, tetrapods or wave breakers. Tetrapods are used mainly to soften the, or to arrest accretion caused by waves. So, okay, here we have, here we can see the application of tetrapods or wave breakers. Okay, so perhaps this structure here is producing these tetrapods. I don't know, I'm not sure. So here we have, we have some, if I'm not mistaken, this is a cargo ships perhaps, which transport precious materials or raw materials for their construction. Let's go to the center part of the island, or is how do you call this, lagoon? Within the lagoon, we have some ships, perhaps cargo ships, transporting raw materials from neighboring areas or islands. Raw materials needed for their construction. Okay, so later on, let's have these ships as our sample for the point features. Let's move this part. This part of the island, we can see a lot of man-made structures. These are big buildings, perhaps factories, we don't know. These features here look like smaller tetrapods These here, if I'm not mistaken, these are cement tracks. These are some of the tracks used for the construction of these structures. So these are perhaps hundreds of structures within this island. What we have here. Okay. Here, if I'm not mistaken, these features here look like a sports complex. Clearly, this is an oval track. I don't know if this is a circuit for race cars. And this here, these look like basketball courts. I don't know if they are going to conduct the Olympics here in the coming years. Okay, so clearly this island is being developed for some strategic purposes. Okay, so now let's start digitizing some features of this island. First, let's sample using point feature. As mentioned, we use point feature if we want to digitize the location of some features on the ground. This time, let's digitize, or let's record the location of these ships here. So for us to be able to digitize, we have to first create a new shapefile layer. So you can go to QGIS menu toolbar and go to layer and then click create layer, and then you can use new shapefile layer, or if you want to use this GPKJ or geo package layer, you can use that one. But this particular shapefile layer is what we use commonly when it comes to GIS. Okay, so alternatively, you can just go to the side toolbar and click new shapefile layer. So new shapefile layer. So first, since we are digitizing point, so let's just have let's name this point layer as. Since we are digitizing ships, so let's input ship underscore location, because we want to digitize the location of these ships. And then let's save this shapefile. Click the ellipsis or the three dots, and let's go to our QGIS vector folder or subfolder. It's important that when we are digitizing, we need to have a file directory for all of our GIS files. Here, ship location, then save. So for the file encoding, just leave it as it is, and then for the geometry type, let's use point, because we are digitizing a point. Then for additional dimension, just leave it as it is. Then for the this is the coordinate reference system. So let's just use the default, which is WGS 84, which uses meters. Okay, so for the name, let's type in ship underscore. Okay, let's just type in ship, and then for the type, let's use text data, and then for the length, length stands for the number of characters that you can encode. Then click add to fields list, then click OK. Okay, now that we have our layer for our point feature, now let's start digitizing the location of these ships. So click toggle editing, and then click this add point feature. Then let's digitize the location of these ships. So click. Then for the ID, just leave it as it is, blank. For this field, let's input ship 1, ship. Okay. Then second, let's have this one. So input, type in ship 2, and lastly this one. Okay. So now we have digitized the location of this ship. So don't forget to click save layer edits so that the information that you have encoded will be recorded. So now we have to. So now if we want to determine the coordinates of this point location or point features, so that we can go to attribute table of this layer. So right click, open attribute table, or you can do this one. You can click this one. So again, now let's determine the location or the coordinates of these features. So go to open field calculator or control I, and then for the output field name, let's first type x coordinates. And then for the output field type, let's use decimal number real. And then for the output field length, leave it as it is. For the precision, let's consider at least 5 decimal places. Then go to geometry, and then scroll down and double click $X for us to determine the x coordinates. Okay, $X, and then click OK. So this would return the x coordinates of the point features. Next, we have to determine the y coordinates of the point feature. Again, output field length. So let's type y. Y coordinates, and then for the output field type, decimal number real. Output field precision, 5 decimal places. Then for the geometry, $, this time y. So scroll down and double click $y, and then OK. So then click OK. So now we have determine the exact location in terms of the x and y coordinates of these ships. So we're done computing. So let's click save edits, and then now we can close the attribute table. So if we want to change the symbology of this point feature, let's say we want to change the symbology for us to be able to easily identify these features. You can change this. You can change this one simple marker to, for example, if you have loaded SVG or vector symbology, you can use this one as a VG marker. But for this particular exercise, I'll just use simple marker, and instead I'll use this this one here. Effect this particular marker. Okay, and I'll click apply and OK for me to be able to change the symbology of these point features. Okay, now we are done with the point feature. Now let's sample, or let's demonstrate the use of line feature in digitized maps. So for the line feature, let's sample this runway here. So let's digitize the length of this runway, and let's digitize the center line of this runway. This dotted line. So for us to be able to add the line feature in our layer, again, go to the side toolbar, click new shapefile layer, and then click new shapefile layer, and then For the file name, let's input line. Okay, just line. Actually, it depends on your preference. If you want to set some specific names or titles for you to be able to easily memorize your features. So for the geometry type, click line, and then again for the CRS, let's just use the default geographic coordinate, which is WGS 84, which is this one. And then for the name, let's type in runway, because this is a runway. We are digitizing a runway. Then for the type, let's just use text data. Then click add to fields list. Perhaps since this line layer will be used for digitizing not just the runway. Perhaps if we want to digitize web network, so we have to create a generic term for this one. So for example, for this field, I'll just use a line. Okay, then I'll add the field, click add the fields list, and then click OK. Okay, now that we have the container for the line feature, again, let's digitize the runway. Click toggle editing, and then click this one, add line feature, and then let's digitize this runway, which is clearly a runway intended for special uses. So again, let's digitize the center line of this runway. Okay, zoom out. You can use the arrow keys of your keyboard for you to be able to move the map. Okay, zooming out for me to be able to get the exact length of the runway. Okay, so again, using the center line as reference, then click and then right click for you to record your line feature. So for this one, let's type in runway and click OK. And then of course, don't forget, click save layer edits. So for this particular line feature, we want to measure the length of the runway. So let's go to the attribute table of this line feature. Right click and then click open attribute, then click open field calculator or Control I, and then for the output field name, let's input length in terms of kilometers. Then for the output field type, decimal number real, because the length not a fixed number. For the decimal places, let's consider 5 decimal places. Then for the formula, go to geometry, scroll down, and then click $sign length. This one, $sign length, double click. So the default value will be in meters. So we have to convert it to kilometers. So type in. So we have to divide it by 1,000 for us to get the kilometers. Because 1 kilometer is equal to 1,000 meters. Divided by 1,000, then click OK. This should give us the length of the runway in terms of kilometers, which is for this one is approximately 2.8 kilometers. So click save layer edits. So let's say we want to change the style of this line feature for us to easily identify this one. So again, double click. So let's widths. Let's say let's change the line color to red. Okay, so since I have already the RGB for red here, so I can just click on it. But if you don't have it yet, so the standard color code for red, which is 255, which is the maximum value for red, this is 255, and then for green and blue, of course it should be 0. 25500. You can do click and then drag it here for it to be saved in the color palette. Click OK. And then I want to change the width of this line, let's say to 1. Okay, so take note that the unit of measurement here of the width is in millimeters. So for example, if you want to use meters at scale, so meaning if you used 1 here, meaning the width of the line will be 1 meter. Okay, so as you can see, if I'll use meters at scale, the exact width of this line will be 1 meter. So let's try to measure. Okay, as you can see, 1 meter. So that's the difference if you use meters at scale in terms of the width. The width of the line will change according to its scale. But if I'll use just simple millimeters, the width of the line will not change depending on this, regardless of the scale of the map. So for example, I'll use millimeters. So this is 1, the width is 1 and the unit is millimeters. The difference is, regardless of the scale of the map, the width of the line is still 1 millimeter. Okay. So now let's sample polygon. Let's digitize a structure here, man-made structure, and let's demonstrate how to use polygon. Again, for us to digitize a new shapefile layer for the polygon feature, so let's click new shapefile layer, and then this particular dialog window will appear. And then for the file name, let's type in a structure. And then for the geometry type, of course, we have to use polygon. For the CRS, let's use the default coordinates. And then for the name, let's just input building. And then type text data because I want to input the type of building. Then click add to fields list. Then click OK. I'll have to specify first where I'm going to save the polygon feature. So I missed the step. I'll have to. Okay, let's redo it starting from step 1. Okay, so for again, click a new shapefile layer and then structure, then specify, then we have to save it to our QGIS file directory. Okay, so I forgot to save also my line feature. Again, as a good practice, you can append or add the CRS of your shapefile. So structure, and then for the geometry type, let's use polygon, keep it as it is, and then for the name, let's use building. Then click add to fields list, then click OK. So again, let's click toggle editing for us to add the polygon feature. Then click this one, add polygon feature, and then let's digitize the area occupied by this structure here. The area. Then it's in digitizing areas or structures using satellite images. please take note that there is always a margin of error, because as you can see, the structure or the image is angled to a certain degree. So you can see there are shadows here. So you have to factor in some margin of error in terms of the area. Okay, so right click, and then for the building, let's input, let's say for example airport. Okay, so now that we have digitized the airport using a polygon feature, let's compute the area. Okay, go to the attribute table of this polygon feature, open attribute table, and then click open field calculator, and then for the output field name, let's type in area in terms of, let's say, hectares or has. For the output field type, type in or select decimal number real, and then for the precision, let's consider 5 decimal places. And then for the formula, let's go to geometry and then select or double click $sign area. Now the default value will be in square meters. Again, if we convert it to hectares, let's divide it by 10,000, because 1 hectare is equal to 10,000 square meters. Again, the preference for what type of unit of measurement that you are going to use, it depends on your the size of the features that you want to. For example, this one, which is a relatively small area. So as you can see, the resulting value is point something. If you want to change it to square meters, for example, let's change it to square meters like that. Then of course the same values here. Then you don't have to divide it by 10,000. So for example, let's just use the default unit, which is in square meters. So click OK. Then after clicking OK, then you'll have the estimated area occupied by this particular airport here in square meters. So click Save Edits. Okay, so if you want to change the symbology, so let's change the color to yellow for us to easily identify it. So again, double click the layer, and then go to symbology in the properties dialog window. Then let's change the color to yellow. So for the RGB for yellow is yellow, since it is a mixture of equal parts of red and green. So you have to input the maximum value of red, which is 255, and the maximum value of green, which is 255. Then for the blue part, of course, 0. So you have the resulting color, yellow. Again, click, drag it to the color palette so that you'll be able to save it as a preset. Then, okay, so I want to color my outline. The outline of the polygon is yellow. Easily, I can just click and then drag it. Click OK. So that's it. So this is the best example in using the different polygon feature or vector types, namely the point feature, which would help us determine the location of the feature on the ground or in our map. We also have the line feature, which would help us measure the distance or length from one point to the second point. And then lastly, we have the polygon feature, which is used to measure the area of structures or features on the ground. Okay. Again, take note, I forgot to save this particular feature here, which is the line feature. I forgot to save it in my QGIS directory. Now, if I want to save it, I can just do right click and then click export, then click Save Feature As. Okay, the format would be I'll use shapefile. Again, geo package, you can also use geo package, but for interoperability purposes, meaning you can open it across multiple GIS applications, shapefile for the meantime is the best option. Then I'll click this three dots here, or the ellipses, then I'll browse. I'll go to the file directory, and then I'll input line. Again, as a good practice, you can include the CRS that you are using. For example, WGS 84. But for this one, I'll just leave it as it is. Then click Save. Okay. Then, if you want to view the exported shapefile, you can click this one, Add Save File to Map, meaning after clicking OK, then this would add the layer in your layers panel, for example. But if you don't want to add it in your layers panel, you can just click uncheck this one. Okay. So here we have discussed, or we have shown how to use or digitize map features using point, line, and polygon. And here we have sampled one of the islands among the Kalayaan group of islands, which is within the Philippine Exclusive Economic Zone. Okay. And clearly this particular island here is undergoing some serious infrastructure projects. Okay, so that's it. Next time we will try to sample how to digitize the different features using preset attribute values, meaning we don't have to input the names or the text in the attribute table. So that's the next part of this digitizing. So stay tuned.